So today we are going to be doing the problem, what is 2 over 2 squared minus 1 plus 2 over 3 squared minus 1 plus 2 over 4 squared minus 1 plus the same pattern as it goes to infinity. So to first solve this problem, I'm going to simplify all of these repeating terms and summations into the general form of the series. And this will involve just simply putting it in sigma notation. So we see the first number, the series begins with n equals 2, n equals 3, n equals 4. So let's write it out like this using the sigma notation. N equals 2 as it goes to infinity of 2 over n squared minus 1. Boom. Now there's not a clear way to exactly solve it just yet. It's not like it's a geometric series per se, and we can just plug it into the a over 1 minus r, which we can derive. So let's break it up into partial fractions, and we could potentially find a telescoping series where the terms will cancel out with one another and reach a summation. So let's do partial fractions. And if you don't know what partial fractions are, I recommend you look them up on YouTube and study them, because it is an excellent tool in so many branches of mathematics aside from not only just series. So first, let's set 2 over n squared minus 1 equal to a over n minus 1 plus b over n plus 1. So we're splitting up into the different factors from the difference of squares that we see here. So now let's solve for a and b. So to do this, I'm going to multiply both sides by n squared minus 1, and this will simplify it, the entire equation, down to 2 equals a times n plus 1 plus b times n minus 1. So now, to solve for our different variables, we could simply just plug in certain n values to cancel out the other coefficient that we were trying to solve for. So, for example, we can plug in n equals negative 1 and solve for b, or plug in n equals 1 and solve for a. So let's go do that. So I'm going to write test n equals negative 1. That will be 2 equals a times negative 1 plus 1 plus b negative 1 minus 1. Boom. Then we will get 2 equals negative 2b, b equals negative 1. Now, let's test n equals 1. 2 equals a, 1 plus 1 plus b, 1 minus 1. The 1 minus 1 will go to 0, so b will be cancelled out. 2 equals 2a, a equals 1. So now we can move the sigma notation that we have up above into the partial fraction form, and this will be equivalent, as I will show you. We need a sigma notation on the other side as well. There we go. So we now have it in a partial fraction form, and we see that these two terms can cancel out from one another, because it almost we could see that it could form a telescopic series. As we go on to infinity, the terms will cancel out with one another. So telescoping series, and this term is very common when we do summation problems. What I mean is, and as we'll see, as I start writing out the terms will cancel out with one another. So to begin with this, let's find the summation just by plugging in the values to these terms. So let's start by plugging in n equals 2 where the series begins. So 1 over 2 minus 1 minus 1 over 2 plus 1 plus 1 over 3 minus 1 minus 1 over 3 plus 1 plus 1 over 4 minus 1 is 1 over 4 plus 1 plus 1 over 5 minus 1 minus 1 over 5 plus 1. And this pattern will go on to infinity to 1 over n minus 1 minus 1 over n plus 1 terms. So this is the summation of the series. And let's simplify this down even further by simplifying all the fractions. So let's find the summation. It's equal to 1 minus 1/3 plus 1/2 minus 1/4 plus 1/3 minus 1/5 plus 1/4 minus 1/6, and this will also go on to dot 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 1 over n minus 1 minus 1 over n plus 1. Okay, so now I've been talking about telescoping series a lot, but let's see what this actually looks like. So let's look for terms that are equivalent to one another that will cancel out each other. So let's see. There are no 1 terms that we can see else in the series. Any 1/3 terms. There are 2 1/3 terms here. Here minus 1/3 plus 1/3. Let's see. Are there any 1/2s? No, we don't see any 1/2s. And okay, we see a 1/4 term and a plus 1/4 term. So we see the series repeating itself in a way where the second term in a sub 0 and the first term in a sub 2 cancel out each other as it goes on to infinity. This doesn't apply to the first 2 terms necessarily, but we can see that this pattern will continue canceling out with one another. So how about we convert this into, since we know these are canceling, let's summate the series as we take the limit of n approaches infinity of s of n. That is going to equal the terms that are not canceled. So the 1/3 term canceled, 1/4 term canceled, the 1/5 term will cancel as well. So the terms that we'll be left with are the 1 plus 1/2 plus 1 over n minus 1 minus 1 over n plus 1. Okay, so we're taking the limit as n approaches infinity of these terms. So the limit as n approaches infinity of 1 will remain 1. The same goes for 1/2. Now, if we take the limit as n approaches infinity of 1 over n minus 1, this will converge to 0. And the same goes for 1 over n plus 1. So what our series ends up simplifying to is 3/2. And this will be the summation of the entire series. So to conclude, the sigma in the sigma notation, 2 over n squared minus 1 was the limit as n approaches infinity of this s of n, and that's going to equal 3/2. So to answer the final answer the final question, what is 2 over 2 squared minus 1 plus 2 over 3 squared minus 1 plus 2 over 4 squared minus 1 continued? It's going to be 3/2, and that is because we split it into partial fractions, converted it into a telescoping series, canceled out the like terms, which you do with a telescoping series, took its final terms and took it as the limit approaches infinity of the summation, kept the initial terms that never get canceled away, and that ends up being the final total of the series. And thank you for watching the video. I hope you enjoyed it.